Make it easy for you. Yeah.
Oh, there we go. All right. We are up.
Are we going?
We are going.
Oh,
Hold on. You're out of focus.
Oh.
That's just what he looks like.
Yeah. He's a little
We're
blurry.
professionals here.
You'd think we would have done that before.
You think we would know what we're doing after 13 episodes?
Oh, absolutely not.
16 episodes now?
This
How
is
many
16.
episodes are we
This is
at?
This is the 16th, yeah.
The 16th Factorio episode?
Yeah.
Okay.
Use that as your way, Joe.
Hello and welcome to your weekly dose of mayhem, the 16th Factorio episode, the only episode with free cookies. That was a terrible throw.
Yeah. Oh my god.
Don't mess up the field.
That's right. Dude, stop throwing them at me. And you know today's gonna be a good episode, cause I'm standing up with the. We're professionals. You know today's gonna be a good episode, cause I'm standing up this time at the FTC field. You may have seen the two most recent videos on the channel. That being Spline path planning for FTC and the Green Team review video. And that's basically what we're going to talk about today. So without further ado, I would like to introduce Anthony. Come on, this is your episode. You got to get onto the thing.
Hello.
There we go. Anthony, one of our programmers and the FOC captain. And then James. Come on. James, the other FTC programmer for Green Team, and the FOC technician. We're the drive team for Green Team.
Hana.
Oh yeah, and then Hana too. Hana's a human player. I'm the coach. These two are the drivers or something. Brady is taking control of a robot. Brady, as always, off screen. He will not be shown.
He's on screen.
Now he's on screen.
Everyone smile for the camera for Mr. Hiller.
I can remember.
Meta.
So, before we get into the robot, Anthony, who are you and what do you do?
Hello, my name is Anthony. I'm the programmer for FTC Green. I am in 12th grade. It's actually my first year doing FTC, but I've done FRC FTC programming. But I did FRC programming for a while. Yeah.
That's surprising.
Maya is looking at us with disgust and confusion from our screen.
I'm not discussing.
Hana, who are you and what do you do?
I'm Hana. I'm the co-captain of the Green Team. This is my second year doing FTC, and I did a lot of mechanical stuff for the robot.
Lucian, the other co-captain, didn't decide to show up, so. And then last but certainly not least, James. Same question.
I am James Burnett. I am the other programmer, not to be confused with the programmer, or other James.
Or other James.
Yeah, or other James. There's more than one of us. And I've been doing FTC for 2 years. And this is my first year doing FTC programming for an actual.
Brady, don't
Brady
roll into my
keeps
front
driving.
room.
Alright. Can they see it?
I think you should move it up closer.
Alright, let's move it close. Brady, put it in the
Give me
middle.
the control.
Brady is on white team.
Brady! You already know that. Brady.
Okay, so before we get on to the programming, we've talked about this guy before. This is Gatubo 2, our second Gobo and the second Gobo. He's
Second go third, counting robot in 30 hours.
all right, fine. Our second Gobo, our third second Gobo, because we're about in 30 hours. Programmers. We talked a little bit about this robot on the podcast before, but now we have him right here on the field. And before we get to the fun programming stuff, we're gonna talk. This guy has a Kiwi drivetrain.
Okay, gonna have to turn it off for that.
This guy's got a Kiwi drivetrain. It's a circle 3 wheels, 3 passive odometry wheels, allowing us to get full field localization. That and combined with the NavX in the middle gives us a very good indication of where we are on the field. The name of this robot is Simplicity. We have a unextending, just rotating arm that rotates at the back off of 2 rev core hex motors. The arm is curved so we can get nice on the ground, and then when we place up at the board, we're at the right angle. A fairly simple hand driven by 2 servos, which just grabs 2 pixels at once, and then a rubber band loaded plane launcher. When designing the spot, we wanted to go for simplicity, and it's been really effective after the redesign that we had after our first qualifier over Christmas break. It's been a very effective redesign. Tiffany, who's on our team, made it look gorgeous with all the vinyl on it. And we've had a lot of success with it so far in the season. And we are looking forward to competing on Sunday at the MVCC Utica New York State Excelsior Region State Championship.
Yeah.
Is that the full title?
That's a lot of words.
It's a lot of words.
At least more than 2.
It was a lot of words.
Okay, I'm gonna.
Wait, should we do? I think we should. Play
yeah.
the match first.
Tele-op demo?
Yeah.
First, before we get on to the talking about the spline, showing off some code, showing off the video, we're gonna do a quick tele-op cycle. So these two, my good friends, Anthony and James, are gonna drive it, and I'm gonna coach them, and Hannah's gonna be a human player. And it's gonna be
New
good.
battery.
All right, let's do it.
All right, I'm gonna switch the camera to wide.
And it's all blurry now. Oh, we're coming
Wow.
back. And we're back.
Hey.
I'll get it.
Interesting.
Hamid, if you're wondering where Hamid is, he's behind the camera as always.
Kind of my job.
He actually won an award today for all his work he did at all the qualifiers that we host. All the match. It's over there. He won an award for doing all the stream stuff at the FTC
He won the
qualifier.
best Hamid award
The best Hamid award.
out of all the Hamids.
And
he's the
he
best.
won an award for all his stream stuff that he did at the 3 competitions we hosted here.
There's like 5 other
What
Hummers.
lines are we being read?
Yeah, we'll be in that. So we're gonna do a tele-op cycle and then we'll get.
Is there a plane in it?
Is there a plane in it?
You guys
no.
never said to show you.
Yeah, let's load this plane. I'll just fill it
Oh.
up where we're at.
Disconnect.
I'll just do this apology now. Nicholas School is trying the very hardest to take away all the time on Friday that we would normally have for this podcast. So I apologize for that, but we will be back next week with another robot review. So look forward to that.
Do you have a plane, kiddo?
Oh, are you driver?
We got an auto timer. Where do we put that?
Auto
I'll put it on the
time.
blue side.
Just put. How would you put it in?
I could.
Well, that. All right, so they're gonna be able to. Okay, I won't be able to see it, but it's fine.
Okay, we gotta put the wrist off.
Well, you can just code from there.
Well, she's got to do it again first.
I'll coach from behind the camera. It'll be fine. Just while they're still setting up the bot, I think we showed this off before. I think last episode we did the TensorFlow model, but this is a prop. Hamid did a lot of work with TensorFlow model, which gives us very good recognition of the prop. So fun. I'm just trying to fill the time.
All right, looks like the plane's in.
All right, are we ready to go? So we're gonna start this. We're gonna start this match. We're gonna start this match right after Autonomous would end in a normal match. We're just gonna show off one of our cycles. We're gonna show off some of the autos later. They're still kind of in development, but you'll get a pretty good sense, and we're confident in their ability.
No, it's just relative. Yeah, try connecting your controller and it won't work in that order.
Okay.
Try doing yours, you just do yours.
At every qualifier, and even now,
This driver station doesn't work. One of the ports doesn't work.
driver station issues as always.
Thanks, Rob.
When did that happen?
Oh, we want to probably label this one question of the manual.
They were using it?
Is this a white
Just because I'm gonna show off Hamid's award.
no.
You know, Hamid, come here,
What?
come here,
No.
come here, come on.
I like being behind the camera.
But you're the co-host. Come on.
I mean, I should be on this side because I'm also technically and programmer. Hi.
So I'm pretty much the only. Well, okay, no, that's not true. But there's a lot of programmers in this room, and
He's not one of them.
I'm not one of them.
Me neither.
Maya isn't either. Hi, Maya. Noah's on.
Probably, can you fix the stacks in the
Who knows
Yeah.
what the
We're like almost.
Who knows what Mr. Hill is? He's an enigma. He's confusing.
Okay.
I see green.
That's not good.
I mean, I'm not real good at filling the time. I thought you would think. You think after 16 factorial episodes I would be better at this, but no.
So I'm trying to.
Hamid, say something funny.
Seconds.
Okay, we are ready.
There's the one. I think there was one spare. But
This
thing on?
that one.
Also, let's just do this. So we can stand over the up.
No.
Okay. Are you ready?
Yeah, Nate, you were gonna show this off.
Yeah.
Oh yeah.
Alrighty.
Let's go.
Cool resin thing.
Miss Wells made this for Hamid for all his stream stuff, so that's cool. Are we ready?
1 second.
No, I'm just gonna.
I have the power of the two controllers.
So Miss Wells
Okay.
did a very good job. She dipped this thing in resin. It was extra control wood black from FTC qualifier, the Buffalo FTC qualifier. It's very cool.
Ready? Crazy in 3.
Yeah, I'm ready. Okay, let's get this match started in 3, 2, 1. Let go.
3, 2, 1.
All right, pick up those 2 purple pictures and let's get this going. All right, awesome. All right, hand them up, put them away from the yellow. Let's get that. Let's not ruin that mosaic. You are at 145.
We can get that one.
You get that one later. All right. Let's get a purple and 2 purples for Hana. Thank you. All right, head through the middle. Not a lot of resistance there. All right, let's try and get that purple mosaic. Don't put them near the yellow. We're gonna try and get that up. All right, we missed. That's all right.
We can grab this one.
Pick that guy up if you can knock it over. There you go. All right, pick him up. Let's get that purple mosaic. You know, we would be. All right, let's get 2 yellows and try and get that yellow mosaic. You are at 1:10. 1 minute 10 seconds left. All right, place though. After we get this yellow mosaic, let's get that set line. Awesome. That's beautiful. Incredible. All right, set line, set line, set line. You have 25 seconds to end game. 25 seconds to end game.
Let's get a set line.
All right, let's just get that set line. That's all we need now. All we need, and then we got the 50. You have 10 seconds to end game. 10 seconds to end game.
Set line.
You can get that set line. We can probably get one more cycle in right at the start of end game. Awesome, that's incredible. Incredible. You are in end game. You are in end game. Yep, we're gonna do this one cycle. We're gonna plane and then we're gonna climb. Standard stuff. Standard stuff. You have 15 seconds left. 15 seconds left. Plane quickly. Plane quickly. Come on, let's plane.
I'm done.
Oh, that's a 30-point plane. All right, let's climb. Let's climb. Let's climb. You have 5 seconds left. 5 seconds left. And you are in the air. You're in the air. You're in the air. Incredible.
Hand up. Hand up. How do we do?
All right, someone's
Okay, what's our points?
That's
We got 50 end game.
50 end game points.
Oh, technically that's not a mosaic. Look at that.
Aw, man.
That's unlucky.
That purple picture's not touching, but that's still a lot of. That's that is 80, 57. 57 plus
50 point end game.
50 point end game and a presumable 50 point auto. That's that was a real good match. Good job. Alright. So now for the fun part that I don't understand.
On the board. 12 pixels on the board without setting up any orders. That's good.
Yeah.
We're gonna be decent.
Now for the part that I don't understand. You may have seen the Spline video on the channel. A lot of people have seen it. We're at like 500 views now after a week. So that was a video that Hamid and James put together off of code that Anthony and James put together. So they're gonna talk about it. Do you have a demo ready for us or an auto that you can show us?
Yeah, we do have a demo.
Alright,
I mean, but we should probably explain it first.
yeah, I mean, take it away. It's all yours.
This one's not working.
Okay, so watch, let's get the robot off here. Basically, back in September when we were doing Robot in 30 Hours, we were looking to the third-party libraries that exist for FTC, and one in particular called Roadrunner, which is used for path planning. And I looked through that for a while, and I was like, nah, let's do this ourselves. And we did this ourselves. And essentially, there's like 3 big steps, and they're all sub-steps in the steps. But first step was if we want the robot to be able, so the goal is we want the robot to be able to go from point A to point B in whatever direction. We want to be able to control the way it goes there. And the first step to being able to do that is the robot has to know where it is on the field and where its target is. So that is localization. which is the problem of where is the robot in absolute position, not just from where it started, but from where the things are on the field. And that's a joint problem with both odometry and April tags. So it's a problem. We have to be able to keep track of a robot as it moves and offset it with April tags. So that was part one. Part two in Spline was, okay, so now we know a robot knows where it is. How do we actually get from here to here? But maybe not on a line because maybe the big truss is in our way. So what if we want to do a curve? How do we do that? Stuff like that. And then the third aspect was correcting and making sure that if things go wrong or things aren't precise, we still end up where we want. In broad terms, and you'll see more of that in the video. Anything to add?
Yeah, I think that just about covers it. Also, if you want to like see the math behind it, the video like pretty much covers all of it.
Well, guess what we have queued up?
What?
Video.
Really?
Is that the video?
Yes. So, if you guys come over here, we can experiment and we can talk a little bit about the video, give our commentary as it's playing. We can skip ahead and stuff like that, but if you guys want to come over here, come on over.
So we'll show the video and then we'll show the video and then we'll show it. We'll do the demo.
Yes. So. I'm going to move all of the stuff.
I'm gonna stand here just so there's something like that. See, this is all the fun technical stuff that you get when you're doing a live podcast, which is live.
You're not live anymore. It's us now.
I'm not live anymore.
It is us now. We're looking down upon the camera.
I'm live again.
Yeah. That's code. Oops. There we go. Okay. So there's not. You guys won't be able to hear the audio, but it's fine because it's just 3 for 1 round music. Cool. So let's play the video. Yeah. All right. Very nice. There it is.
So first and foremost, I have to say, and you guys did an incredible job on the editing of this, Harmon and James. It's very nice.
Exquisite.
Yeah.
So, do you want to skip ahead to some of like the first math parts of it?
Sure.
Yeah, this is just talking about localization. This is actually talking about something last year, which is actually completely different from what we did.
Yeah.
But followed the same kind of concept.
Yeah. So we can skip ahead to.
Too far.
Whoa.
Okay. So.
Yeah.
Yeah. There we go.
Spline.
So yeah, the big concept that this is using is that if we take a bird's eye field of the view, we can pretend it's a coordinate plane and define curves on it. And our first thought was that, well, it takes in one corner, scoring's in the other, but we can't go in a line because the truss blocks us, so we kind of trying to take a curve. And our first thought of doing that was a cubic function, as it shows. That's the first thing mentioned in our video. And about how odometry is going to update our position so we can keep moving along it using our x value and derivatives. You want to talk about the first correction thing? Is that you?
Yeah, so, also, I think later on we ended up switching to logistic because it fit better and also let us go through the like skinnier trusses. But for correction, like the simplest way that we could correct is just based off of distance. So if it's however much off of the y, then just correct to account for that, and you can see that it does correct. Although, and it did work, and it looks really cool when it gets kicked and then it just goes back.
I'm gonna move the microphone real quick.
The issue was an optimization error, and also in some cases, when it would correct, if it was in certain spots, it would end up just going back into the backdrop and then just hitting it.
So this video is actually from September. It was in our Robot in 30 Hours, where we still had a Mecanum bot. And this was actually, I think, our first test, or one of our first tests of this whole concept.
Yeah, that's when I remember seeing you guys kicking it and it's still going to the same point like multiple times in a row, and it was just so impressive because I didn't actually think it was going to work.
So this part is actually about the correction stuff he's talking about, where it didn't correct very well, which was the main problem with this first version of our spline.
It also required tuning a correction constant, which when you ended up getting multiple curves was really annoying.
Yeah. And now this is about to segue into parabolic spline. There you go. It's the title right. I said that was kind of cool. Which is, the concept is, instead of correcting to the curve, you have the curve correct to the robot, and it will always bring the robot to a certain point. So
that point right there, that does not ever change. That's the vertex of the parabola, and that's where we're trying to go. The animation is a little misleading because it shows both sides, but we really just sort of end at that vertex.
Yeah, just a logic statement there.
Yeah. So it doesn't keep going after that point. It stops there.
Yeah, I think right now it's about to show an animation of all of them, all possible paths converging to there. So it doesn't matter where a robot is or where a robot gets kicked, it will end up at that point. So if that point is somewhere we want to be, this works out really well. And yes, the main thing that made this viable is you can just kind of put them all in piecewise and use 2 or 3 together and traverse the field as this Desmos shows.
Here we use a linear as well, I believe.
Yeah, there's a line in the middle.
I think that got changed to parallel.
You could use either in that situation. Ah, yes, this video is awesome. I love seeing this one.
Yeah. So that's the same math that you saw in the graph on the field.
So yeah, the one of the weird problems with parabola is chaining it in certain ways was a little mathematically weird. So, and also the main problem was it's a function. You can't go in a U-turn on that because you can only have one y value. Talk about the solution.
Yeah. So.
Wait, hold on.
Yeah.
Oh yeah.
It's my-
Wait
it's my-
until it does it. Yeah.
This
Sorry,
is the
function rules.
one. This is the one animation that I made.
Didn't you make all these animations in Desmos?
Yeah, I
Yeah.
could have learned a proper animation software, but why would I do that?
I mean, for math animation,
I'm
basically, Desmos is
yeah.
good. Yeah.
All the Spline and Spline math stuff, correct me if I'm wrong, but I saw most of it in Desmos, and it looked like you did a significant majority of all the math in Desmos, which was
It got to
really
certain
wild.
points where switching between writing the stuff in Desmos and writing in Java was really confusing. The formatting, like I had.
And here's Bezier.
Oh, yeah,
Bezier!
All right,
Which is actually not the final solution anymore. But
yeah, it
go
is.
on.
Our video's out of date.
We'll get to that. We'll get to it.
That's after. Okay, go.
So, the joys of Bezier is it doesn't care about function rules or is this continuous in all derivatives. No, it just does it.
You can see how it has 2 values for one x input because the x isn't an input anymore. So it can like bend over itself basically, which is good.
You can do just about anything with these, and it just doesn't care. And if you like chain them like we did with the parabolas, you can make just about any path you could possibly want. And this ended out working really well until the nightmare that is realizing it's a parametric and you have to deal with t. So t, since it's a parametric, it's not defined by x and y, it's defined by t giving you a point. Whoa, perfect time.
There we go.
Oh, it's almost like we made the video.
Whoa.
Yeah, it's crazy. But getting the desired t based on the distance is really hard because the distance function is complicated enough that you can't set the derivative equal to 0 and get the local minimum that way. So instead, we had to do distance samples, like hundreds of distance samples per loop.
Which is this, actually, I think this animation is about to
Yeah.
show it. So, like, to find the closest point to the curve to which it wants to correct, it has to iterate over the whole curve and figure out approximately where the closest is, which isn't computationally inefficient.
Yeah, it's a little bit inefficient. Also, we're plotting the points on the smaller...
Yeah, that graph on the left is the distance.
Based
It'll
on
it'll put the labels up, but it is the plot of the distance.
So yeah, that local minimum is where you would want to correct to.
So yeah, this did work, and we ended up using it at both the Utica, not the States thing, because that's in a couple days, but also Corning. Yeah, no,
Yeah.
So we ended up using it at that and Corning, and both times it ended up working surprisingly well, given this computational nightmare. But the thing which was probably the most important about this is how it corrects back to the curve. So since we have the closest point on the curve, we don't have to worry about the optimization of the x and the y. Okay.
Sounds good.
Hi, Mr.
Oh, wait, this is talking about correction.
Oh yeah, correction.
The thing what we're talking about.
So yeah, this what we're having it do is based on the distance on the perpendicular axis and the tangent axis. We're having it project a point along the tangent axis based on how far it is on the vertical axis, and then that ends up making another lerp function to get back onto the Bezier, as this animation does. And this ended out being what led us to our final spline. Because what we could do is if we put the correction distance as a ratio between the distance along the normal line and the tangent line, we were able to do what parabolic spline did, except without the issues of parabolic spline, where it's like, oh, if it enters anywhere but the vertex, it doesn't work as well. So now we have a better spline, which just uses the correction of the Bezier spline, and the curve corrects to the point. And also,
And this is a nice Blender animation.
Hamid knows how to use Blender.
The Blender animation.
That is
So this is going to show, I believe, pictures from our, yeah. So this is going to show videos of us doing the Bezier path, which looks awesome. And I think one from the competition.
Yeah, there's one from.
These
that's
were
not a
our,
competition. That's just testing.
Yeah, it's been for me as a mechanical guy. It was real fun to see.
Oh, here's autonomous.
Oh, this was.
This is against Gorilla. This is against
Yeah,
Gorilla.
this was the finals. This was finals 1 from Corning. That was a good match.
Yeah, we played so well then.
That was a real fun match for. I thought we played real well. So.
Yeah.
So yeah, that is the video, right?
So yeah, this is wrong.
Yeah,
How
it's
did
not
they-
a-
Yeah. So yeah. So
Whatever do you mean?
So-
what is the new iteration?
so we've had we had localization. We have the spline concept. We have actually now we have 4 methods of doing it. One where you do a basic function and correct to the curve. One where you do a basic function and correct the curve to the bot. One where you do a parametric function and correct the bot to the curve. And then what's the last one exactly?
I don't honestly know. It's a mix of everything.
Yeah, the last one's a little weird, but it works awesome.
Call it hybrid.
Call it hybrid?
Yeah.
There we go. Yeah. All right, back on the field.
Back on the field.
Back on the field we go.
Are you gonna run some autos now?
We could run an auto, yeah.
Yeah, great.
So,
Are you interested in showing off code or not just yet?
what?
Are you interested in showing off code or not?
What do you mean by showing off code?
You can fill it with it.
I'll go with that, yeah.
I can't.
I already know exactly what you show the code. It's right. Okay, let's just do it.
Who hooks up?
Center left. Yeah, center left. So currently, with the 4th auto, we, for testing purposes, have it actually stop at every waypoint and actually kind of hone in on it before it continues. So you'll be able to see that. For competition, we're hoping to actually just have it go continuously without stopping.
Correct me if I'm wrong, but is it true that we've implemented the the little switch? We put a little switch on our robot that changes whether it places in like the left or the right column on the board, and is that working well?
We have the functionality. We have to tune it a little bit more, but we will have it.
Last minute auto tuning before competition is always fun, but let's show it off.
Assuming it didn't crash. Hey, it didn't crash. Okay, let's do it. So first path is to the purple pixel drop. We put the arm down, place the purple pixel, make sure we didn't miss our yellow one. And from there, we drive to a 2nd waypoint, stop, drive to a 3rd waypoint, stop, 4th waypoint, stop, 5th waypoint. It's a longer one. Then we drive to the last waypoint, which is right in front of the scoring area,
Place the yellow.
and we score.
Perfect auto. Good job.
And that's the auto.
I'm so happy it works for the camera. I mean, it's been working, but
Now
I
you're gonna have
thought.
to walk home, Anthony.
So yeah, that's
It's an example of the auto.
that's one of our autos. For other teams going to going to FTC States tomorrow in Utica, you'll probably get to see us in action. And if you have any questions for us, we'll be around, so you can always ask, always come up and ask. This has been a real fun experiment and a successful one at that. For all facets of our team, it was real fun. It was real fun and real interesting. Having to figure out just on the mechanical side of things for me, how to get all those, how we have to get all the odometry just so precise and the cameras exactly where they need to be, and NavX right in the middle. If you want to show off some code, feel free. And then that's all I've got for me. But
Yeah, if you want to.
let's talk about brief. We can show
So,
a little bit.
so there's some stuff to talk about with the code,
Yeah, get down.
which is
Come on.
we're gonna have the camera on us.
Yeah.
Face cam.
Face cam? Face cam? Hold on.
Reaction
Let's
channel.
get in the face cam.
Anthony face reveal.
So, I think I already said that this was my first year doing FTC programming, so I kind of started this year knowing nothing, and it kind of shows in the code because I have made 5 different repositories for one robot. Or I guess it was 3 robots in total.
Just
But
wait till
anyways,
he discovers branches.
but anyways, yeah, there are 5 different, like, not versions, 5 different, like, I guess versions of the code base, but each of them has many versions of it. So code got iterated a ton. The final version, are you able to pull up the GitHub?
Yep, I've got it here.
Oh, that's just okay. So anyways, if we were to expand the right side all the way, we would see that there are about 30 to 40 to 50 even Java files that make up the whole thing, and all are essential, and they're all distinct. Code from previous years has been done maybe in like 5 files, so we essentially just went bare bones and made, like from scratch, made all our own custom functionality, everything we would possibly want. Math utilities, extra controller functionalities, tons of like templates for like autos and teleops, tons of what am I trying? Anyways, tons of versions of testing code, so we can test all our functionalities on the fly, stuff like that, just to make it easier at competition. You know anything to add?
Not that I think of. Yeah, pretty much covered it.
I mean, we could go into depth about some of our like
Yeah.
some of our
If you want to like showcase a
utilities.
couple of classes.
Yeah. So some of our math utilities are pretty cool. We made our own point vectors, robot pose storing code, and we also added a smoothing algorithms, like sort of similar to motion profiling, that can smooth our drive inputs to make sure we don't have jerky motion when we're driving. I made one for a single value and one for actually a coordinate, which smooths its 2D motion. And we actually use that on our drivetrain to make sure it doesn't like instantly accelerate or decelerate. And it makes all of our driving really nice. Yeah.
Any of the spline stuff that you want to show off, like the
Oh yeah, we can do another spline demo if you want. So we can do a kicking one actually, just to show that this is not like dead reckoning or this is not very easily breakable.
Yeah.
The odometry works how it's supposed to.
yeah, the actual code for the spline is
So there's 2 files. There's lerp path planning and there's parabolic path planning.
okay,
And
yeah.
parabolic path planning is pretty bare bones because we don't use it for much anymore, but lerp path planning has everything it needs to have.
Okay. And back on the field.
Back on the field, let's run the...
Do you remember what
Kicking
lane
on
it
it.
was?
What?
Do you remember
I think
what
it's
way?
forward and to the right.
Alright,
So we can just kind of like set it up here, have it kind of do this, or do
Uh-oh.
that, and I'll just
Takes
kind of
a
like
second.
kick it that way. Yeah. No,
It's way cooler if you kick it like to the other side.
Camera.
Camera. Watch it correct on that way.
no, if I actually ask to redefine to go down instead, it's pretty cool.
Okay.
Hamid, is there any way we could do it over there and have the camera like high enough to see there? Because we don't have, I don't know if we have enough room this side. We probably do actually.
What? Where do you want to do it?
If we can do it here, I have a little more room to work with. You should
I
do it
think
here.
do the one where it goes from like that side. Do you have that? Something that can go from there to there?
Oh no, I didn't make one of those. I just have the small one that you kick in and it goes back.
Okay.
Let's do that. Let's just run that because the
okay.
kicking demo's gone.
Yeah, you can run it over.
I hope we have enough room here. I don't remember how far I told it to go. If it doesn't work, we'll run it on that side. So yeah, here's what we're gonna do. I'm gonna start it on this tape marker. We're gonna start it, and we're gonna see where it ends up. I forgot how much distance, so we're just gonna mark it. And what we're gonna do is we're gonna see where it ends up, mark it, bring it back exactly where it started, drive it again, and I'm going to kick it like a foot or 2 feet off the path, and we're gonna see it go back. Although it might hit the truss because that might be in the way. I don't know.
I'm gonna get feedback. I'm gonna zoom out.
We'll see if we have enough space. This is not usually done on the field. This is more so for the judging room in the pit. Okay, so yeah, we're ready for you to start. Okay, so let's see where it goes. Okay, that's pretty good. I'll mark that.
I got it. No, I got it. I got it.
You got it? Oh, tape works okay. Just put like a line there and a line there. You could mark with pixels though.
Yeah, we could. So yeah, that's how far it went. This
So
way.
wait, which one did you use? Is that the lip one? Because I think that one's different. No, okay, you did the parabolic one. That's how I set it up. Okay, actually, we're gonna do it again because we actually have 2. I set the position for one to look better, but we did the other one.
Is it path planning demo?
Yeah. Okay, hold on. We're gonna do it again. My bad. Start it like here, actually. Let's put a pixel in between.
2 robots versus 3 and 1
Okay, hit it. Okay, so this one is doing parabolic. Okay, yeah, it needs more space.
in.
Yeah, we should.
Yeah.
Let's just do the other one. It's fine.
The other one is I can't really kick it into the wall though, so
You can kick
I don't
it.
think any of them really work on the field. I need more space.
You can overshoot it.
What?
Like you can kick it like beyond it.
I don't think do that. I wouldn't be able to go back to the door though.
You're running
Just
on the
don't
FOC
kick it
field.
beyond the door.
Yeah, can we just kind of like do it on the ground because that works?
Okay. Yeah, we're professional. We know how our own demos work.
Definitely. I mean, how long did you?
What do you mean you aren't prepared?
You know what's happening. Fucking everything open.
Yeah, just pull the table off.
We've moved on to the FOC field now. Oh yeah, there's your evidence for the 30-point plan from the telly episode. There it is. I love this thing. Watch.
Okay. Do we have the camera pointed here? Let me just actually mark where we're starting. Something. Water bottle.
Are we doing Pathfinder testing?
Yes. Path planning demo. We got
So that's our starting point.
Cool.
Enabling.
Run it. This is gonna go in a parabola.
Hopefully not hitting any chairs. It's
Yeah,
fine.
good enough. Okay, well I can't really kick it because actually I'll kick it this
Yeah,
way.
kick
That
it that
works. Okay, so let's mark that with tape.
So now we're gonna mark it.
Give it
here.
like a teeny bit of space. Yeah, okay, that's good.
Yeah, we're gonna mark it there. Basically just flush with this line too.
Yeah, I mean, yeah, fair enough. Okay, so yeah, the logo should kind of be
The logo's gotta be
on that tape
piece
line,
of tape. So let's
essentially.
reset it.
Okay, so let's put that back and run it again. Make sure I get the starting position right.
Yep.
Wait, let me get the angle right as well. Angles have got to be good. Let me get one more look at it. Yeah, looks about right. Run it.
Yeah. Kick it a couple times. There you go. And it's gonna end.
Yeah, table, but whatever.
I mean, that is basically where it was last time. And so that's pretty impressive. As you saw in the videos, we've done that with the mechanical drivetrain too, which was real cool. That's just always my favorite demo, the kicking one. If we had more room, we could do it do it way more extreme, but
Yeah. Also, the carbon made me not kick it as far, but
yeah.
usually we can. I put the wheels on float for while it's driving for this demo, so usually I can like get like a whole like 2 feet or
We
something.
can send it.
Yeah.
So, if you've got do you have, it seems like we're running out of time here, but do you have any last things that you would like to say?
I don't know, Brady. What about you?
Cheese from Brady. James, what do you think of the spline stuff? Good job on the video, by the way.
It is in fact a curve.
Anthony, any final words of wisdom?
Through bore encoder on everything.
Throw it everywhere. Mr. Hitter, any final words of wisdom?
I like that one. Through bore encoder on everything.
Tuble encoder on everything. Well, that's all I've got for you. And we're gonna send it off. We'll see you next Friday. Good night, everybody.